So this is the atom test review. When number one deals with electrons that have gained energy and moved to a higher energy level. So what that means is you got a nucleus surrounded by electron energy levels. You have an electron here, it moves to a higher energy level, so it has gained energy. So we call that an excited electron. That's letter A, excited. When Thomson was thinking about atoms, he had atoms were like a solid sphere like this with little electrons stuck around inside like plums in a plum pudding, and he called that the plum pudding model of an atom. John Dalton was the guy that developed atomic theory originally. He's kind of known as the father of modern atomic theory, and that's around 1800. The part of the atom that contains the protons and the neutrons would be the nucleus, of course. That'd be the center of the atom. That'd be O. And energy levels deals with the light demo that we saw with the glasses, where we put on the glasses and looked at the lines of light. That was Niels Bohr, B-O-H-R, so that was letter E. Directly related to energy of light and measured in hertz has to do with the how many times the wave goes up and down like this, up and down, up and down. Remember, we used the spring in class to reference that, or to illustrate that, and it's measured in hertz. It's called the frequency. So G is frequency. Subatomic particles with zero charge would be neutrons. Neutrons have no charge. They are neutral, so that'd be H. Negative charged particles are electrons, and electrons have a negative charge and no mass, and that's F. The scientist already said his name that developed the plum pudding model was Thomson, and that would be, of course, be letter I. A subatomic particle with a mass of 1 atomic mass unit, that'd be a positive subatomic particle, and that's a proton. That'd be letter P. 2 protons and two neutrons. Remember, we had the gold foil analogy, and the particles were shot from this little box over here, and they went through this gold foil. Most of them just went straight on through. Those were alpha particles. Alpha particles was choice J. Each color of light has a specific what? What do we call the distance from here to here? We call that a wavelength. And the short wavelengths, if you have one like right here, you can tell just by watching me draw on the short one and the long one. Which one did I have to go up and down more on? It was the one with the higher frequency. So shorter ones are high in energy, which have a higher frequency, and the longer ones don't take as much energy to draw, or in real life they don't have as much energy. So anyway, bottom line is wavelength. Wavelength is K. When electrons return to the ground state, and remember this electron up here had moved away from the nucleus, when he comes back down, he'll give off energy. So when he comes down, they lose energy. The answer is B. We see that energy in the form of light. Okay, the alpha particle guy was Rutherford. Rutherford was choice M. Words that describe an electron that has not yet gained energy. So it's just in this normal unexcited position. We say that's it's grounded. It's in this ground state, unexcited. And then a region where you'd expect to find an electron, that'd be an orbital. And we call this. So like the orbitals are like the beds in the pink room and the sunny room. Okay, I'm going to go ahead and, I'm going to stop it there, and we'll save that as the matching section.